I need some nerd
We
shirts.
need to do this a bit more down there. Look at this, and the man should be in the shot here.
Yeah, he should.
Yeah.
Are we ready?
Oh, we're recording
Do
already.
you want the hi guys, hi nerds, or
Okay.
I'll do hi guys, you do the hi nerds.
I'll do a hi guys. Come on, this is the usual thing.
I'll do the hi nerds for a change then as well.
Okay, yeah.
Okay.
Let me do the hi
So-
notes. Okay.
I'll do 3 taps on here, yeah?
Okay.
Hi nerds!
Wow, this is totally synchronized.
With synchronization, yeah. Hi nerds. Okay guys, so we know a lot of you rather enjoyed our little chit chat last week, and we're back for some more, yeah?
Rich invited me over, so yep.
Yep.
You have to live with me. Sorry.
Exactly, yeah. And this guy's got a sense of humour apparently, so I've heard in the comments.
Sometimes. not as bad for as some Germans, yeah.
Nah.
I think.
Detlef definitely has a very dry sense of humour, I know about it. So we're here with another sponsored PCBWay video, and we just want to chat about a couple of projects we talked about last time, because we've discovered a bit more, and one thing we discussed a lot was how a particular soldering station worked.
He meant we went down some rabbit holes.
Yeah. No, we it means that Det actually had a look at the PCB.
And I was screaming at my screen.
Screaming, yeah. So, where are we up to? Well, we still have the Tim's Hotplate project, and we've been chatting with Tim. So I'm just going to show you how inexpensive this thing is actually going to be to put together. And I think we can put together a really good hotplate. So we'll just go over to that interweb thing.
Ooh,
yeah, let's have a look. And here we are. So this is Tim's Hotplate. Now,
and it's of course on PCBWay.
of course on PCBWay.
Yeah.
And we've been in some discussion with Tim, and this uses what's called a PTC heater, PTC hotplate, and we can buy these things really inexpensive from AliExpress. There are a few different ones around. His project actually uses a solid state relay with a triac to drive the heating plate. So as long as a triac is powerful enough, really they should be able to handle more than one heating plate.
Oh yeah, you wanted to have more than one, right?
Yeah, what I'd really like to do is something like this.
Oh,
Where we can have
fancy.
several of them. And look how cheap these things are. 99 cents each. Yeah.
400 watts. Okay.
400 watts, yeah. Now, I mean, the preheater on my BGA station is 2 kilowatts.
Mm-hmm.
So I'm guessing 6 of these are just a bit over that.
Yep.
Yeah. And that would really be able to handle big
for
PCBs.
this price, man.
Exactly. So Tim may come back together with us again, just to say that actually you can't, guys, but this is what we would like to do, or maybe we can work it out between us. I've noticed actually, so this is a soldering ball and a demolition board tool.
Oh, so okay, we can demolition stuff.
I think that's what happens mostly when you try to do BGA rework. It is demolition.
Yeah. True.
So at least they've been honest about this product here. So that I like that. They also have these in a 110 volt versions as well. So all you guys should be able to build this project on the slight chance we actually get it to work properly. But no.
Wait for this, please. Please don't rush this.
But,
so PTC means that you. Oh, this is not a thermal runaway thing, right?
Yeah. So I didn't know this. So Tim actually told us how a PTC heater actually works. Is it has a positive temperature coefficient, so that means its resistance increases with heat. So the hotter it gets, the higher the resistance gets, which for a given applied voltage means the lower the current is. So he says basically that a PTC heater will heat up to a certain temperature.
Oh, and this is why they can say 400 watts, because this is probably the max, and then it will equalize there somewhere.
Yeah, it equalizes at some point so that the resistance gets up to such a point that it won't get any hotter. But if it cools down, the resistance goes down, so it just balances. So it's really the thermal mass of this thing that keeps it at the right temperature.
So how do you control the heat?
Exactly. So Tim was explaining that you can't control these things with like pulse width modulation.
That would be my choice.
Yeah. What you can do is effectively turn them on and off periodically.
Oh, like a thing in your stuff at home.
And your stove and the oven, you
yeah.
set the oven temperature. It's actually you hear it clicking on and off. So you can monitor the temperature and then switch it on and off. And Tim says actually that is the tricky bit with this. But he's really happy to get more exposure for his project, so he's working completely with us. We have all the information. I'm sure between us we can really do something well with this. So that's that project. But
while talking about projects, if you guys out there have an idea for a project, we all game. If you need some input for that, or if you want to do a collaboration with the two of us, the three of us, Carlos would be in too.
Absolutely, yeah. So
just let us know, because this could be a fun thing. The builders community is more a solitude kind of crowd.
Nerds.
Yeah, the nerds. Yeah.
The nerds.
But we try to do this a different way. To do more communication here, to do more collaboration. Yeah, it makes the work more fun.
Yeah. If you really like this, we may go back to doing like the instant premiere where so we can all watch together and such like. Yeah.
True. Yeah.
In fact, yep. So that's another possibility, or even a bit of live. Yeah. So let us know what you want to do, guys. Now, anyway, talking about PTC. So this comes to something quite interesting. And if you remember last time, we were talking about the controller for soldering irons. This is the one that works with, here we have it.
Warning, rabbit holes ahead.
Rabbit holes ahead. So this is C210, C245, and RT series from Weller. And we were looking at this previously, and I'll just get it on the screen. There. This is the schematic for this soldering station that we looked at last time. And the conversation and discussion was that this effectively has a big linear transformer, 24 volts, 5 amps, and a bridge rectifier, but there's no smoothing capacitor here, like no bulk capacitor. So we kind of figured out that this must be like a chopper circuit. So it's effectively detecting here the zero crossing point, or when it reaches zero, because obviously being pulse DC, it doesn't cross zero, but it reaches zero.
You probably can drive the tip with that, but we were thinking, why does he do that?
Why does he do that? And somebody also said, why can't you put a big power supply on here DC? I'm saying, well, because the chopping thing won't work. And then somebody came up with a clever idea. He said, he said, if you could inject into this a square wave at 100 hertz, it's got its crossing points, although this is all DC. And therefore, by having the crossing points, it knows when to trigger the chopper. And I then thought, that's a very clever idea, but let's go one more. We have a little transformer here, which is cheap, driving the 5 volt supply. And if we put a diode in here, so it's conducting forwards, that means the capacitor is smoothing on this end of the diode, but this end of the diode is the output from the bridge rectifier. And we can use that to feed into here. And that's how it can go with the crossing points, without having an oscillator running at 100 hertz, So we were looking at this, and I discussed with Detlef here, we were chatting about this, and Detlef said, let me have a look at the layout of the PCB.
There's you bring up the screenshot for that.
Yeah, how can we best modify this to work in this way? So the idea is you use a very cheap transformer, low current, because this is only providing the display and the 18 meg
10 mil or something. It won't take long.
That can be a very small one, and then this we can use a DC power supply, which is much cheaper. So Detlef went off and had a look at that, and guess what he found?
I came back screaming.
He came back screaming. Because here is the PCB.
And
can we enlarge this? Control mouse wheel. Saved. So
look at the big elephant in the room. It's called C9.
Yeah, the elephant in the room called C9, which isn't on the schematic. 4,700 microfarad, 35 volts.
Last time I looked at the schematics, I said, wow, this guy knows what he's doing. And then I came across this and I thought, what the heck? Why the schematic isn't the same as the PCB?
Yeah, and look where it's connected, directly across the output of the bridge rectifier, the big one. Yeah, which powers the soldering iron. So it is DC.
It is DC.
It's just that the schematic, which we have,
it's gone again.
It's gone again. Shall we edit
it? It's in the download.
It's in the downloads we did. So the schematic that we had, but it's kind of like got lost. That thing, okay. I only wanted one. I got two. That capacitor is actually connected across here.
Yeah, it is. So you got over the supply voltage for the soldering iron is DC.
Yeah, it's DC.
Heavily smoothed DC. Yeah.
So we then sort of thought, well, if that's the case, then what the hell is this thing doing? What is all this for? I mean, that one, obviously the designer has looped it back to itself so it doesn't oscillate.
Yeah, this is a good idea to do that.
But what's this doing? So we had a look and we can see that the cartridges here have 3 connections on them. Okay, and we can also see that this plug is actually on the soldering iron itself. So that's the socket, and that's the plug. And if you look, they're both wired with one which is ground.
Earth. Let's say earth.
Let's say earth because that's what it is. Yeah.
So this is really like a earthing wrist wrap you got for when you're doing the
like the ESD stuff. Yeah.
ESD. Yeah. This is ESD.
This is the radiator pipe you hold.
Right.
Yeah. Well, you got your other hand in the high voltage stuff. Yeah. Perfect. That's that one. Yeah. So that is ground. So there's actually 2 connections going here and 1 more from pin 3, and pin 3 is this one. So if you look, when you plug this type of cartridge in, it connects pin 3 to pin 5, and when you connect the other sort in, the 245, it doesn't connect pin 3 to pin 5. So what this is doing, this one, is detecting which type of tip you have. It's obvious now. So this ground, if we look, is actually mains ground. There's actually only 2 connections to the soldering iron tip. Now, we were thinking the soldering iron tip would have like a heater and a thermistor, or thermocouple. Heater and a thermocouple.
Rabbit hole?
Another rabbit hole, so it doesn't. So what we decided then to do was to have a look to see what we could measure on a C245 cartridge. And we have one here. So I think you guys would be really interested to see what we found. So to do this, I'm going to make a little bit of space because we don't want to melt any PCBs. Because what we're going to do is take our C245. So this part of it, this is ground. This can either be grounded earth. So this is earth. Let's call it earth. This is earth.
Please.
So this can be earthed or not, depending on whether you prefer to have your soldering iron tip earthed or not. There are certainly, in my opinion, advantages and disadvantages both way of that.
Yeah.
So whichever you prefer, and you can debate that in the comments, guys. Should we or should we not let our soldering iron tip roll away?
If you run it from PD, USB PD power bank, for example, you get 20 volts with 5 amps.
And it's not earthed.
It's not earthed. So would be an option too.
It would be an option too.
Another one.
Yeah, that's true. Yeah. So we're going to ignore the earth. The earth is not part of the circuit.
And this is the outer sleeve, so where Richard got his finger.
That's this. So we just left with the other 2. So let's get the multimeter and let's read the resistance of the heating element in this. Okay, so we want to go to resistance range. Ohms.
Oh, you can use this with the tips. No?
Yeah.
Okay.
And then we measure across the heater.
what? This is all over the place.
2.3, 2.2. So it's very low, this heater, about...
Must be.
1.8. It's 1.8.
Let's call it 1.8, yeah.
So I then thought, because we just read the thing that Tim had said about PTC, and I thought, is this a PTC heater?
Let me hold the tips, and
you hold the tips.
You do the heating.
And we're going to find out. So the best way to find out if this is a PTC heater is to measure the resistance of the thing.
2.1. I see 2.1.
And then I'd watch this finger here.
Okay, try to watch it.
So we measure the resistance, yeah?
2.4.
And then we heat it up with hot air.
Go for it.
2.9, 3, 3.1, 4. So without burning jet any further.
No, it's not. It's not.
6. So guys, this soldering iron tip is a PTC heater.
Was I in shock there?
You were.
Okay, good.
Because you can see where he's measuring it.
Oh yeah, and it's holding it.
It's holding it now, but because this is quite warm.
Yeah, I believe that.
That's quite warm. Even touch it with my fingers makes a difference.
No, not really.
Watch. Ow.
All for science.
All for science.
Yeah, all for science here.
So this thing basically is a PTC heater. in our opinion. Guys, what's your opinions? Yeah, but we think it's a PTC heater.
Yeah, so as we said before, this will have a certain max temperature in there, probably for 50 or 500 degrees.
Or something like that, yeah.
And then you do the thing like your kitchen's oven does.
Yeah.
Switch it on, switch it
Switch
off.
off, switch it on, switch it off. So that's how we can see. It's the only way we can figure out that this thing actually works.
Yeah.
So
And we're thinking that it puts in some current, then it switches over to the measurement circuit over there.
yeah.
So this is the thing around U12, around the LM358.
Yeah, because if you look on these two wires here, which go to the heating element, that one is connected to ground, chassis ground, not earth. Okay, which is ground for the op amp, and the other one has a resistive divider. Yeah, so one resistor, two resistors. That's to the ground. So this is a voltage divider. R1 and R3 is a voltage divider. And then this is a clamp, isn't it? To stop it going more than 0.6 of a volt. And obviously, because the resistance of the heating element, the PTC, is increasing, then the voltage here will increase as it warms up. And with bit sure, that's how it knows what temperature the bit is at. And this just effectively sends a signal to the 80 mega.
This will be an ADC input there.
Okay.
Yeah, against the AREF from the TL431.
Yeah. And that's how it knows basically to switch on and switch off. So we think it's just switching it
We
on
can't
and switch
tell
off.
because there's a hex file. So hex file is a compiled version for the 80 mega,
Yeah.
but there's no source code. And I hate it when I don't know what the thing is doing and we're building something. We can't modify it the right way around because we don't know what it's doing and we can't change it anyways.
True.
So besides a complete rewrite, which I'm not happy with,
No.
which I would not be happy to do, this is a this is a project.
Suck it and see, I believe.
Yeah,
is
this
the
is
correct term,
suck it and see. Yeah, this would be if it works, fine. If it doesn't work, we're pretty much screwed.
Yeah. Don't say that at the gay pride, by the way.
Oh yeah, we won't say
Suck it and see. No. So, by the way, guys, I've just noticed this isn't a resistive divider because that isn't connected there.
No.
So this just monitors a voltage coming in
It
on
is.
here.
Then it's clipping off the
yeah.
maximum voltage to 0.6 or something.
And then
you can set the trim point with RV1.
RV1 here, yeah. So this basically this is a resistive divider.
And you can tell by 1.5K and to maximum 250K, this will be a very low voltage on the
15K to 150K, yeah, and then it's actually you can vary this. So this sets the temperature, and it's comparing that, which is a reference with this. So this is basically doing two things. One, it is detecting whether or not we actually have that type of tipping to pin 3. And the other thing it's doing is monitoring the voltage on there. That's the best I can see it anyway. I can't think of any other way that would actually work.
There's another thing I'm not quite happy with. See let me give him the mouse so the people can see what I'm pointing at.
Yeah.
See the A over here? It's from pin 6. This points
That's
to
ground.
A and this points over here. No, 6 is not ground.
Oh, it's not. Oh, sorry,
No.
my mistake.
And now have a look down what pin 6 is connected to.
Nothing.
Nothing. Indeed. Nothing.
So A goes to nothing.
Yeah, and this connects over here to PD3 on the microcontroller. If I had the source code, I could tell you what it does. I don't have the source code.
We can see there's a Zener diode, so it can't go below 5 volts.
This is probably just a safety thing to cut off anything above 5 point to make the 80 mega safe.
Yeah.
But again, no idea what this is.
Exactly.
And from the schematics over here, which we know that isn't complete, no idea what this is connected to.
No, I agree with you. And also, you can see that on the soldering iron tip, there is only the 3 connections.
Yeah.
So 6 doesn't go to the soldering iron. Well, it can't because there's no more connections on the cartridge.
Well, the thing is from 2015, so it's now 9 years ago.
Can I just suggest something?
Hit me.
Maybe 6 does go to the handle, and it's the signal that says you've moved it. So it's
this could be a switch on the thing.
Yeah, because this shows the connections on here which go to the actual cartridge. So pin 6, I suspect, doesn't go to the cartridge. It can't. There's no more connections. But it's probably the vibration detector. So now I think that's what A is.
Okay.
That is A. Yeah, that is must be what A is. And it's clamped, and so this knows if you haven't moved the soldering iron in some period of time, it goes into start.
This sounds reasonable. Yeah.
Okay.
Absolutely reasonable. Yeah.
I think I solved that one.
Yeah, you did.
Okay. I think somebody already typed that in the comments several minutes before we actually got that far. Okay, so that's what, as much as we think we know about these cartridges that they are effectively PTC heaters.
Yeah. Can you switch this?
We can switch that off. And thank you very much, Tim, for giving us that information inadvertently because you didn't know you were solving that problem. So, Tim, again, do you think we're right on that one? Yeah, and if not, what do you think? Because you obviously know something about heating.
He does, yeah. He's a nice guy.
Yeah, he is.
And again, guys, if you have projects, let us know.
Exactly.
Yeah. By the way, just to have a little rant here, I'm not happy with this project because there's questions there. And as long as I don't have the source code, we're pretty much screwed.
Yeah.
Don't say this on a gay pride.
But exactly.
This is the thing with PCBWay and the shared project thing. You have to look very carefully before you start putting energy in there.
Yeah.
Because if you've got a project that isn't complete, source code's not there, or again, this is from 2015. It says somewhere down modifications.
Yeah, it does.
So this is 9 years ago. Chances are that a Google Drive or a share on a server died in the time between. So you're stuck without software.
Exactly. I mean, this is not an issue of PCBWay. The shared projects, as I say, this is an open forum for people to put their designs, and they do say so. So I suppose at the end of the day, it comes down to who uploaded the project.
Yeah, I do. Yeah, it does.
And very much on the same topic as that, actually, which leads us on nicely from this to this. So this is a Milliohm meter. It actually reads down into the micro ohms. And I built this. This is a PCBWay project. These are my homemade Kelvin probes, because Kelvin probes are rather expensive. These are made out of SMD, like the tweezers you put on the multimeter. I soldered the ends together and found that they would still come apart, so they got a nice bit of insulation.
Which is actually a clever idea to do this way.
I think so, because it works just as well as a Kelvin probe, but these things are like €1. And if you look at the price of Kelvin probes, they ain't cheap. Yeah. So, okay, so this is the project I built. Now, this uses 2 op amps. They're like a 741, but they're OP07, and they're more of a precision op amp. And you'll see if I short the Kelvin probes together, this pretty much zeros itself. Takes a few seconds to do it, but it will just go down to 0. Okay.
Wow.
Yeah, and stay there on 0. If we take something of very low resistance, like a shunt, which is one of these things. So these, I think, were very, very low resistance. I don't think 50 milliohms or less.
Let's find out. You can measure this.
Yeah, let's measure. So we go across the shunt like this. That's around about 2 that's reading, and this one was reading about, it's about the same now. Yeah, 2. So they actually read when you get a good connection onto the thing, because obviously we're talking extremely low resistances. They actually read about the same. Now, one of the viewers said that he couldn't find this project on PCBWay, which is what you're saying about people deleted them. I honestly don't remember who you were or which video you put the question on. I actually gave you the link to the original project, saying he may have actually deleted it. It turns out he hadn't deleted it. It is on PCBWay, so in the description to this video I will actually give you the link. And the reason you couldn't find it is because it was actually an Italian project, so it says Milliohm Meter rather than millimeter or something, or something like. It's in Italian, so it's spelt a bit different, and unfortunately the search wasn't clever enough to work out that there was only 1 hour or 2. Yeah, so the link to this one is actually in the video description. And I say this is a very simple device. This just uses a couple of op amps, and that's it. While I was looking for the links to this, I actually found some more Milliohm meters, and you can't have enough Milliohm meters. in my opinion. Oh, I can't.
I borrow mine. If I
Yeah. Det borrows them if he wants one. Yeah, I can't have enough of them. So, guys, I found this, and this is where Det and myself were chatting again. So, what I found on PCBWay was two things. This is one of them, and this uses an Arduino. And the other one is this one, which is a little bit unclear what it uses, but we think it's a OLED display.
Yeah, this has some problems there. Yeah. The guy talks. There's a link to I think his webpage, and he talks about how he constructed this, and he says this is actually a merge of two different projects.
But he does have the source code for this one.
Yeah, and then there's the schematics, and there's a bomb.
Okay, so we're back. We just had to get some files there. I forgot to mention, these are the types of power supplies I was going to use for that soldering iron station. It says 24 volt 5 amp, but you can see I can actually buy a 24 volt 10 amp for €8.50. I mean, we could say go 8 amp, which is $7.92, but to be quite honest, there's no real difference.
This is probably cheaper than buying a transformer.
Oh, yeah, I couldn't even find a transformer of this rating. And the sort of kit I would normally look at is like old battery chargers and the sort of power supplies you use for home station CB radios, but they're 12 volt. Or UPSs, but again, they're 12 volt, the ones I see. And amplifiers with our big transformers, but they're higher voltage. So I couldn't find a suitable transformer for this.
Yeah, and for €8 for it. 240 watt
power brick.
Yeah.
I mean, obviously they go up in price after that, but I mean, 15 amp is only slightly more. But 10 amp is enough. I mean, that is enough for this project. And hopefully it'll fit inside the enclosure I want to use for this as well. So that's that bit. The Milliohm Meter, the one that I built, I just want to show you. So this is actually the original project. He's a Brazilian guy, so he would be Portuguese speaking. Is it Brazil?
Probably. Yep.
Yeah, I think so. I think so. And he actually spelled his Milliohm Meter with like one L. So he did put it in English, he just didn't spell it right, and that's why you can't find this project easily. Okay, and it reads down to 10 megohms, not milliohms, microohms.
Milliohm Meter, it's probably says in Brazil.
Yeah, Milliohm Meter.
Portuguese,
Yeah. So that's that project, but the link is in this video. So the ones who want it, you now have that.
Yeah,
okay.
And it's a super projector. Look at this.
Yeah, super projecto. Progetto completo.
Yeah, I love this. Progetto completo is really nice.
Yeah.
I don't care about super, but
they would also say a progetto completo.
Progetto
completo.
Yeah, some similarities to
Spanish. Yeah, exactly. So that's that one. And the one we're going to just chat about now. Now, we haven't looked at one of these yet, so this could be interesting.
Drop him in cold water here.
Okay, in the cold water, Detlef. So this is the schematic. Now, I know you had a look at this one.
Yeah, we are.
Would you like to kind of try and describe what's going on here?
Yeah, this is the Milliohm Meter from Curious Scientist.
And have a mouse.
Let me show the people the... no, that's this one. That one, yeah. Curious Scientist. So if you're looking for a Curious Scientist and look for the project is Precise Milliohm Meter.
Yeah, I will put the link into this video description as well for you guys.
He actually has a website, and he explains on the website, and I guess he explains a lot in the YouTube videos, but sadly there is not much description for the rest of that. So no written description. You get all your information out of the video. Which reminds me, this is actually how I do this.
Oh, yeah.
Yeah, mostly, yeah.
Come to think about it.
Yeah.
It's mostly how you do it. Yeah, exactly.
Yeah. So he has his components over here, but no explanation what they do. And there are some really things we had to look up. I had no idea what the LM2940 or the LT blah, blah, blah.
Yeah, we had to look these up.
We had to look this up, yeah. So back to the schematic. Yeah, over here. So let me zoom in a bit. This is this one. Right?
This is this keyboard. Yeah.
So some voltage regulation from a 9 volt.
9 volt in.
We got a 5 volt over here.
Yeah.
Then we have a precision current source.
A bit like a TL431.
Yeah, but with precision in the front
And
of
you
it.
can put a voltage on the pin one
Yeah,
rather than the
and
resistor network.
Yeah, it can be controlled from a voltage over here. This is what this thing does. And then there's a resistive network here that you can trim with this pot
So
here.
that's eight 100 ohms or
Yeah,
when
12
parallel.
something.
Yeah, we said 12.5. If this one with the trim is trimmed to read 100, then it's 12.5 ohms.
Yeah, so this would be the current, and this is actually some current. I calculated something about 212. So this could be about 200 milliseconds.
Yeah, 200 milliamps I think was the maximum. I mean the Vici Milliohm meter and the one I built both give 100 milliamps.
Yeah.
And that's quite standard for these sort of things.
Yeah, I have no clue what's actually coming out of this thing, so guesswork here. And this goes into the EMA 106 here. This is a voltage to ADC, I guess. Yeah, this is a 24-bit ADC.
24-bit ADC, that one, okay.
Yeah. And
the Max 680, that
the
one.
Max is a funny little chip. Give it 5 volt and it produces plus 10 and minus 10. This is actually a thing like you do on a Max 2H232. You maybe had used this when you do serial communication, because serial communication does plus minus voltage too. And this simply uses single positive voltage supply and transforms it into plus and minus 10 in this case.
Okay.
It uses the 4 caps over here for that.
Okay.
So charge pumps.
Yeah, okay, fine, yeah.
Yeah. And now then all the shebang goes down into this thing over here. No, I'm wrong over here.
Well, I did say so. What's this piece?
Yeah, I have no idea what this is doing. I think this is something voltage plus, and voltage plus comes back over here. This is the ADC, by the way.
This is the ADC.
ADC 2000, 24-bit ADC. And this goes somewhere into the Arduino. If you ask me where, I have no idea.
Yeah. And the display?
Yeah, the project has actually a display, because you want to see something on this, right?
Yeah.
Tell me where the display is.
Well, it says SDA-SCL.
Yeah, sure.
So it says
Could be.
I2C LCD con. So it goes to an I2C LCD. Does that tell you anything about it?
Yeah, from the source code here. What is this? Go away. No, right now, not right now. Thank you.
From the source code?
From the source code, I can tell this is an SSD 1305 display.
Uh-huh.
So you have to look up in the source code what this is, and this is for the display. It's used I2C.
Okay.
Uses Adafruit display. So this is something really, really standard. And I guess from the pixels here over here, this would be one of the lengthy ones.
Okay, 128 by 32. Is that is that like the displays we were playing with before?
Yeah.
I'll show you guys one in a minute when Detlef. Well, in fact, I'll even show you one now.
No, this is not one of those.
Not one of these?
No.
Okay,
this
forget
is,
that.
This would be liquid crystal.
It's nothing to do with that. So I thought it was
No,
it's
an OLED one.
Okay.
It's an OLED one, a little one. So what I really like, the source code is in there, and it's documented, and I can pretty much tell he does, when you look at the loop, what's the loop? This is how I would write the loop.
Yeah.
So you got calculate the voltage, calculate resistance, print OLED. This is how I would do that. I probably had my loop at the end of the thing, but doesn't matter for this one. So this is pretty much very self-explanatory.
Explanatory?
Thank you for saving me that. Yeah,
Explanatory.
That's what I meant.
Explanatory. That's the one.
Thank you very much. But I'm not really happy with how this is handled, because the components aren't in here. With the BOM, you don't get the Arduino, you don't get the display. I can tell by this thing over here, ground 5 volt, clock data, this will be the display.
Yeah.
But, man, I hate this. It's not in the schematics, it's not very good. Ugh.
Yeah. And that software is just if
this is only used, so
that's what you
brings you
use.
to the Arduino KiCad download page.
And he explains where he originally found it. So there's your list of components.
Yeah.
And there's a download bill of materials.
But active parts list, where's the Uno? Where's the display?
Yeah, he doesn't include them, does he?
Yeah.
Okay. There's another problem with this project. Hit me, because he's hit me. This bit here. So he's saying the maximum resistance you can measure is 5 ohms. Don't go above this value, Otherwise, you can damage the ADC.
Oh.
Well, I mean, why are you going to build a Milliohm meter that if you just have to stick it on a 6 ohm resistor, you're going to trash the ADC? So if we were to build this thing, guys, there's 2 reasons why we might build this, or 3. One is because I'm very interested to see how this performs compared with my simple analog 2 op amp Milliohm meter, which is as accurate and just as good as the Vici one. But this has many, many more parts.
And it has strange parts.
It has strange parts.
This is not something I have in my stock.
So, did I say there was 3 reasons? Yeah, I did. So the second reason we might want to build this is because we would want to improve this. We would want to get rid, or rather not get rid of, but kind of like, there's a word for this, mitigate. We'd like to mitigate this problem. Now, you can't do something like put a resistive divider in 10-to-1 to make this 50 ohms instead of 5 ohms because, well, to be quite honest, the one problem is you're going to reduce the sensitivity by 10 times. And that's the last thing you want to do with a Milliohm meter.
Indeed.
So, guys, that is a big issue, but if we can take away swarm
Intelligence, yeah, please. If you got a better design. I don't like this project because it has so many moving parts and feels a bit over engineered for me.
Yeah, and the third reason I like to build this is because I know it annoys Det.
It does. It does. Yeah, he's right with that.
So on that topic, and just moving on one more, we found this one. Now, this doesn't mention any limitation with the 5 ohm resistor. It appears to be quite a lot simpler to build. Can we expand that? There.
Oh, fancy.
So this, in some respect, we can see the same sort of thing, a constant current source. Yeah, this is using the op amp as part of the constant current source. Probably that would make it much more accurate than just using like resistors, yeah? So that's a constant current source. Is this an ADC?
Oh yeah, this is an ADC. Yeah, I work with these in university.
Okay, which then goes into an Arduino Nano, and we stick our display on the end. Is that the same sort of display the other one? No, it's not.
No, this is like the one you had just said.
This is like this.
Yeah, this is like an LCD.
That's that one. Okay, so we're more inclined to build this project. A, because it's easier. B, because we have a lot more of the parts here. And C, because it doesn't annoy Det so much.
Absolutely, yeah, absolutely. Yeah.
But guys, what do you think? What do you think?
I like this one because this feels like a thing that really I could follow this and I can tell you how this works. This is a big upside for me.
Yeah.
The other one with all the fancy schmancy chips on there, well, I didn't like this very much.
Yeah.
And this feels like they're doing a differential one. See, IA on the ADC.
Yeah, here.
Yeah.
Oh yeah, they do the differential between the 2 points.
Yeah.
Yeah. Is this a bit like the embedded Mr. Bleep works?
Yeah, it is.
Into the multimeter.
Yeah. So we measure 2 points of the measurement resistor, and we get a differential reading over this.
Yeah. So again, guys, we have the source code for this one. The link for this one is in the video description on this video. One other thing I forgot to mention, so I will just mention, back to our other rather nasty thing. Even Det's got me thinking that. If you wondered what this chip does here, which only has 2 connections used, ground and V out, this is an extremely accurate voltage reference at 4.096 volts exactly. And we think this thing here, we had a quick look at the data sheet, so you can control the output from this, and we're pretty sure this effectively drops about a volt. So the voltage here going into the Kelvin probes is about 3 volts, which is about right.
Yeah.
So that's what that thing does, if you wondered about it.
What this does in the final installation, let me go back to the link because I just saw this over there. In the description down here, it tells us Milliohm Meter uses a very simple principle, Ohm's law. We apply a known current 100 mil to unknown resistor and measure the voltage across the resistor.
Yeah.
So, where were you at this? So over here at this point, this thing over here generates somehow, some magical way, generates 100 mil. To me, this feels like a very complicated way to generate 100 mil. Well, of course, it's precise. I know. I get you.
Yeah.
but it still feels a bit over-engineered.
Yeah, I can kind of get that. So again, guys, do you think that this thing would perform notably better than my simple 2-op amp circuit? Which I suppose, just to complete this, we better just show you, hadn't we? My simple circuit on the one I built. So, and here is the schematic. So again, we have in this case a TL431 doing what that fancy stuff is doing. We have an op amp, okay, which is driving a MOSFET. This again forms a constant current source.
See, this is the same as we saw in the second project.
Yeah, we have the constant current out and the sense in, and we have another op amp connected as a comparator, which has a certain amount of gain, as I recall, and that drives the display. So the display meter here, this is like one of these little modules that you just buy from AliExpress. So that is the very simple version that I built. And again, if we're going to build this, I think it's mainly because I'm just interested to see is whether all this digital trickery is any better than good old op amp analog circuitry. So,
okay.
I mean, what do you think, Dad? Do you think like the...
This is not Richard's, this is a video that's playing there.
Oh, yeah. Okay, yeah. Okay, I've stopped it. So, do you think that the digital shenanigans version is actually any better than this analog thing, which I built, which we've tested today, and it works pretty damn well?
Yeah, I'm not sure if it's better, if this is a thing. For me, since I'm more of the digital one, I like my digital thing more.
Yeah.
But this is simply liking. This has nothing to do with functionality.
Yeah.
So I guess we won't get better than this one. Nearly in the ballpark.
And this one, which I'm just going to open it up if that's anything finalised, I'll show you what's inside. So this thing is actually a prototype which I built. The project is on PCBWay, of course. I built the prototype. I think I may have ordered the PCBs, but the prototype worked pretty well for me. And we can see that it took a little while to settle, but its zero's okay. Once we got a good enough contact on that shunt, it's ready to just basically the same. I mean, I don't know how well the VC4H is calibrated, but this gives the same reading.
Yeah, it is.
And yet this thing, when I show you what's inside it, guys, this is so much of a Heath Robinson, is that the correct term? Heath Robinson.
Who's that?
It's an English phrase that basically means something that's thrown together.
Okay. See, I learned something today.
A good use of Heath Robinson is villains of Gotham City. When you capture Batman and Robin, don't kill them with some conventional methods, such as a knife or a gun. Don't leave them unattended to the fate of some Heath Robinson invention of your own creation. So Heath Robinson device.
I'm learning stuff here.
Yeah. Some Heath Robinson killing device of your own creation.
Oh yeah, Transformers.
I think
that's broken loose.
It's broken loose. Okay, so guys, that is what's inside this. Oh, I tell a lie. No, it is a PCB, and this is my power supply, which is on a bit of Vero board. So that's what's inside this one.
You know, one thing I'm always sensitive about is component count.
Yeah.
And maybe the analog one uses more components than the digital one.
Certainly not as many as that's over-engineered.
Yeah, the Korean scientist one. The Euro one, if it works fine, and did we check the source code from the Euro one?
We have it.
We have it, but we haven't checked it.
We haven't checked it yet.
Okay, let's have a look. Let's have a peek. This could be a showstopper.
Okay, so over to...
You want to switch over to this monitor, I think?
So guys, this is the source code to the other one, like the sort of simpler, if we like, Arduino one. Jet, you've not looked at this before, so
no,
at first glance, what do you think?
Just reading this here. Yes, it's a bit convoluted, but I can tell ADS 1015, blah, 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 blah. MCP 74725. I have no idea what this is for. Liquid crystal, yeah, this is a display. This looks nice. I think it works.
Do we go a bit further down? Oh, bounce. This is like a debouncing thing. He spells it funny because he's not an English native speaker, but we have this bounce input. This is when you get the Kelvin probe, so it knows it's getting a steady reading. Is that right?
Oh, yes, it could be. Yeah.
Yeah, and then
there's some Russian or Ukrainian commands over there. Yeah, loads of if statements. You know, if it works, I won't judge. This is fine. You can tell he knows what he's doing there.
Yeah. But the great thing is we do have the source code on both these projects.
If we want to modify this, we could. If you only get the hex file, so the exported file, you're stuck with works or works not.
Uh-huh.
And what I really like is the component count. We are way lower on component count than the curious scientist one.
Okay, well, I'm going to order some PCBs from PCBWay. So I'll order all the PCBs anyway, and then we can take it from there. So you guys, you'll have the links to all of this in the video description if you're interested. Have a look. And I think we can all meet again next month and see where we go from there. Yeah. Okay, so that's enough, I think, from us today.
It is.
So one more thing to say.
Pleasure being here, mate.
Always a pleasure, Det. And one more thing is, bye, nerds.
Bye, nerds.